Welcome Math 10 to your lesson on rational and irrational numbers. So let's start with a little warm-up here. We're going to figure out which one of these are rational and which one of these are irrational. So convert to a decimal. Let's convert each one to a decimal. First one, we look at this and we have 28 divided by 11. What does that give me? 2.545454. This looks like it goes on forever, doesn't it? My next one is 28 divided by 8. What does that give me? 3.5. My last one is the square root of 2. I get 1 point. This one goes on forever as well. Well, there's probably words for this. This one that goes on forever and looks like there's a pattern. This one that doesn't go on forever. And this one here that goes on forever where there looks like there is no pattern. There's probably words for that. And there are. They are these definitions here. There's repeating decimals, which is pretty common sense. Non-repeating decimals, okay, decimals that don't repeat, okay, terminating decimals, which are that terminate. So let's look at this one. This one here is going to have to be repeating, and this one's terminating. This is non-repeating and non-terminating decimals. Well, both of these are non-terminating. Non-repeating would be this one and this one, okay? So let's take a look at this here and see. I have a little exercise here for matching. Let's see if we can match everything correctly. Alright, so we look at the first one, 1 over 8. Well, punch on your calculator. What do you get? You end up getting a non-repeating and a terminating decimal because it terminates. It doesn't go on forever. Let's take a look at the next one, 2 over 11. I look at this one. Well, it is repeating. Everything is repeating. It's going on forever. If we punch it into our calculator, and this is also non-terminating. Okay? Now, let's try my next one here. Let's try 9 divided by 7. Well, I look at this, I'm going to have 9 divided by 7. Okay? And I end up getting something that looks like this. Now, I look at that, and what do I have? If I look very close, we get 1.285714, then 28, and then 6. If I was to expand that 5, 7, we round that up, that 5, that's 6. So this actually is non-terminating, because it looks like it goes on forever, and it is not, and it does repeat. It is repeating. Okay? Let's take a look at my next one. This is already in decimal form, 0.94 repeating. Well, this is non-terminating, and this repeats. Okay? Now my last one, square root of 8. Well, we take the square root of 8. We can't find that all. That's 4, or that's going to be 2, square root 2. That's interesting. So this is non-terminating. This one here is non-terminating, and it is not repeating. Okay? Now let's take a look at my last one, the square root of 16. Well, that gives me 0.4. And that's it. So this one here is going to be terminating, and it is also non-repeating. There's no repetition. Oops, that's non-terminating. Non-repeating. Alright? So there we go. We just went over some very good examples. Let's try my next set of examples here. Now we want to know if a number is rational or irrational. What makes a rational number? A rational number is something that could be put into fractions. Or in other words, a rational number means it has to have some kind of repetition. An irrational number is something that cannot be put into fractions. Or it is something that goes on forever. It's a decimal that goes on forever and we cannot put into repetition. So let's look at the first one. 1.493. Well, this is going to be rational because it terminates. Square root of 5. When I plug it in my calculator, it looks like it never terminates. That's irrational. I cannot put that into fraction form. My next one is 2.347347. Well, that 347 is repeating, so this one here is going to be rational. My next one is negative square root of 81. Well, that's going to be negative 9. So this is obviously rational. Next one is square root of 4.41. Let's try that out. 4.41. Push enter. Oh, I get 2.1, so that ends. So this is rational. My last one here, we have 122, 221. 1, 2, 2, 2, 1, 1, 1. Well, this is not really repeating. There is kind of a pattern here, but it's not repeating. It's non-terminating. Therefore, this last one here is going to be irrational. Okay? Okay, so now we want to put these here on the number line on whereabouts we think they are. So let's go back to my sheet here so I could write it in. Let's try the square root of 14. I look at this, we have square root of 9 is equal to 3, and I have square root of 16 is equal to 4. So 14 is closer to 16 than 9. So that's going to be closer to 4. So we're going to get 3 point, I don't know, something, high 3s. So I look at that, and this is going to be A. My next one is 3.14. Pi is right here. This is B. My next one here is square root 80. Well, that's 2. Square root 20, right? Because we can take out a 4. Square root of 4 is 2. Then we can take out another 4. So it's 2 times 2. Square root of 5. 5 is going to be 2.1 or 2.2. So it's going to give me something around here. This is going to be my C. Okay? Because this is going to be 4 multiplied by 2 point something, which is going to give us there. And our last one is this here, 15, is once again in between these two, but closer to 16. So that's going to be like 3.8 maybe, and multiplied by 2 is 7 point something. So this right here is going to be my C. Okay? Oops, sorry, that's D. Okay? So that's all we have to do for this one. Now the next one here is we want to convert repeating fractions or repeating decimals or decimals into fractions. So how do I convert decimals into fractions? This one right here, I'm going to show you a different way. We're going to say that's equal to x, right? Now I want to get rid of the decimals. How do I get rid of the decimals? I multiply by 10. So I go 10 multiplied by 0.3, which is the same as 10 multiplied by x, which gives me 3 is equal to 10x. So then x is equal to 3 over 10. There's a reason why I'm doing it this long way. This one here, make it equal to x. Multiply by 100. So I'm going to have multiply by 1,000. Okay, is equal to 1,000x. Now I'm going to divide both sides by 1,000. So I get, So I'm going to get 345 divided by 1,000 is equal to x. Alright, so it's kind of like that. So we get 345, we got rid of the decimal, then we divide by 1,000, and I'm going to end up getting x. So there it is in decimal form. And then we can simplify this and do that. Now let's take a look at these repeating decimals. This is how we do it in a calculator. I'm just going to go like this. I go 0.44444444444, and I'm going to go math, and go fraction, enter, and it gives me 4 over 9. Okay, so it's guessing. But there has to be a way to do this algebraically. And look what I did here. I first made my decimal equal to x. So we said 0.44 repeating is equal to x. Now I've got to multiply this by something. What do I multiply it by? I'm going to multiply it by 10. Multiply everything by 10. So I get at least one of the repeating decimals on that side. So I'm going to get 4.4 repeating is equal to 10x, right? Multiply both sides by 10. Now I look at this, there is a way I could get rid of my decimals. I'm going to subtract from this. So if I go 4.4 repeating, subtract 0.4 repeating, I'm going to end up getting 10x subtract x. Isn't that the same thing? Yeah, because we said 10x is 4.4, x is 0.4 repeating. Now we could take these away. I'm going to be left with 4 is equal to 9x. 10x, take away 1x, gives me 9x's left. So I end up getting, divide both by 9, divide by 9, there we go. 4 over 9 is equal to x. So let's try my next one. Let's try these here. So I look at this. What is my problem? My problem is there's 2 there. 2 numbers are being repeated. But we can still say, we still have 0.56. We're going to make that equal to x. Okay? My problem is there's 2 numbers here that are being repeated. So I want to get at least my whole repetition on the one side of the decimal. So how am I going to do that? Well, I can't multiply by 10. So if I multiply by 10, I get 5.6565, right? and there's a repeating there, is equal to 10x. I can't take away yet. Let's try if I multiply by 100. I get 56.56 repeated, and that's equal to 100x. So I have to multiply everything by 100. So now I look at this, I could go this, subtract this, will get rid of my repeating decimal. So I go 56, subtract, 56.56, repeating, subtract 0.56, repeating, is equal to 100x, subtract x, which ends up giving me 56 is equal to 99x. Alright, almost done. Now I just divide both sides by 99. So I get x is equal to 56 over 99. Okay? Let's take a look at my next one. Only the 5's repeating, that 3's not. How do I do this? Well, this is make this first equal to x. So then, well, what's 10x equal to? I'm going to have 3.5 repeating is equal to 10x. Now if I subtract this, my decimal isn't getting, I'm not getting rid of my decimal in any way, am I? No, I'm not. So let's try another one. Let's try 35.5 repeating is equal to 100x. Now, is there anything that I could subtract? Do I look at this? If I take this and subtract that, there goes my repeating decimal. My decimals are all eliminated. I could eliminate my decimals. So let's do that. We're going to go 35.5 repeated, subtract 3.5 repeated is equal to 100x, because this is equivalent to 100 multiplied by x, because that's x, subtract 10x. All right, what am I going to get? Here I'm getting 90x, and this here is going to give me 32. Okay? So, we go 90 over 32 is my answer. And both those can be divided by 2. We could simplify that, so we could get 16 all over 45, and that's about it there, okay? So 16 over 45, if that simplifies too. Let's try the next one. We have 3.45 repeating. So that 4, 5 is repeating, so I'm going to let this equal to x. All right? Now, what am I going to do? Multiply both sides by 10. So let's see. We want to get the repeating decimal over. So I have 34.54. And then it's going to be 5, 4. So it's 5, 4 repeating is equal to x. Now 5, 4 is not the same as 4, 5, isn't it? No, it's not. So let's try one more. 34, 5.45. And it's 4, 5, 4, 5 repeating. Oh, this is 10. This is 100x. So now let's subtract. I could go this and that. So I'm going to have 345.45 subtract 3.45 is equal to 100x subtract x, right? Because this is the value of 100x, this is the value of x. I take those away, I'm going to get 342 is equal to 99x. Divide both by 99. This is going to give me 7, 9. And both of these could also be divided by 9, so that could be simplified. So let's take a look at this. We know 342 can be divided by 9. It's divisibility rules. I get 38 over 11, which gives me 38 over 11, which is equal to x. And if I want to put this in mixed fraction, I can still do that. So I'm going to get 3 and 5 over 11 as my answer. And there we go. Okay? So, that's everything. Hopefully you understood the whole assignment. And I'll see you tomorrow as we work on some things together. Good luck. See you tomorrow.